In this video, let us see about write invalidate protocol using write back. In write invalidate protocol, we have three states: invalid state, shared state, and exclusive state. In invalid state, the data present in cache line is not useful. In shared state, we can perform only read operation on the data. In exclusive state, we can perform both read and write operations on the data. Here is the state transition diagram of write invalidate protocol, and here are three states: invalid state, shared state, and exclusive state. And all these lines are transitions between the states. So let me explain write invalidate protocol using an example, and this is the one. It is better to note the example to have easy understand while watching video. Here is the example, and initially let us assume that we have two processes P1 and P2. Each process has single cache line. It means that each process has only one cache line, and each cache line is in invalid state. Each cache line is in invalid state. And we have bus. A process, whenever it wants to perform operations, it gets control over the bus and performs its operations. Next, let us enter into example. So here, first operation by P1, R of A, where R represents the read operation on the data A. So as cache line is empty, it's a miss. So the read of A miss was placed on bus, so that P1 gets data from the memory into its cache line. So the state of cache line moves from invalid to shared. So here on read miss, we are moving from invalid state to shared state. So here the cache line is at invalid state. By read miss, it's moving to shared state. Next, the operation is by P2, that is read B. As P2's cache is empty, the read B is miss. So the read B miss was kept on bus, and P2 gets data from the memory into its cache. And now the state of cache moves from invalid to shared again. So again here also, by read miss, we are moving from invalid to shared. Next, read A from P2. As we are having single cache line and we have next to operation on different data, we need to replace the data. So this B was replaced by A now. So this is miss. As in cache we have B's data, so read of A is miss and it was placed on bus. And now P2 gets the data from the memory. A was placed in cache. So this cache line was completely replaced, that too from shared to shared. Previously this cache line has B in shared state. Now it has A in shared state. So we are moving directly from shared state to shared state on read miss. So here from shared state to shared state on read miss we are moving. Next, write of A. This operation was performed by P1. Here, whenever write operation occurs, we need to check whether there is a bus hit or not. That is, what is a bus hit means that whenever one or more process has same data, then we say that it's a bus hit. So as we got a write operation, we need to check whether there is a bus hit or not. Here both P1 and P2 has same data A, and P1 wants to write A. So we get bus hit, and bus generates invalid signal to P2. Invalid signal has been generated. So now the cache line, the state of cache moves from shared to invalid. Shared to invalid. Then P1's cache moves from shared state to exclusive state. From shared state to exclusive state. Here if we observe on write miss, a cache moves from shared state to exclusive state, and another cache moves from shared state to invalid state. So here we see that from shared state to exclusive state we are moving by placing invalidate signal for write miss. See here, for write miss, by placing invalid signal we are moving from shared state to exclusive state. That is what this representing here. Next, we are moving from shared state to invalid state by write miss. So that's what. Next, we have write operation on B. So here the cache line was invalid and we got write B. So it's a miss. So we placed write miss on bus, and here again we need to check bus hit or not. Bus hit or not means that here P1 doesn't contain info about B. Data B is not present at P1, so there is no bus hit. So we can directly get the data from the memory to P2's cache. So P2's cache get data. So the state of P2's cache moves from invalid to exclusive. As it is write, it's moved from invalid to exclusive. Next, invalid to exclusive on write miss. Here invalid to exclusive on write miss. Next operation, read B. Actually in P2 cache B is present in exclusive state. In exclusive state we can have both read and write operations. So Even we can perform read operation in exclusive state, so that read B in P2 is a hit. In exclusive state, read on same data or write on same data is a hit. Next, write of A in P2. Sorry, read of A in P2. This is some complex because here P2 has, as P2 has single cache line, it has to place it the data has to be replaced in P2's cache. But the exclusive state, it means that the latest copy of the data is with the process. As the latest copy is with P2, the latest copy of B was with P2. So this has to be stored back to the memory. This is called write back. We are writing back the value of B or data B onto memory. Okay. Next, here again we are placing a read A as it was missed for P2. We have placed read A in bus. But it has bus read hit. We say bus read hit or bus write hit. We have two hits, bus read hit or bus write hit. Whenever an operation, whenever a miss comes into bus, it checks whether it's read hit or write hit. It means that if a write miss is there on bus, then bus checks whether the processes, more than one processes contains the copy of it. If yes, there is a bus hit and it generates invalid signal for write operation. So it is bus write hit. Next, whenever we get read operation, it checks for bus read hit. It means that when one or more processes have same data in the cache, and if it is in exclusive state, then it's a bus. Then when it is in exclusive state, then bus makes that process to write back the data. If it is in shared state, nothing is done. Let me explain again. When we get a bus hit for read operation, if any process for the same data is in exclusive state, it has to write back, else nothing is done. So here there was a read miss and the data at P1, data A at P1 is in exclusive state. So this made to write back into memory. Here we write back into memory, and this made from shared exclusive state to shared state. Now cache line moves from exclusive state to shared state. Next, so now P2 can get the data into cache line from memory. So shared state. Previously, at this point in this cache, B is in exclusive state, and now A was in shared state. So we are moving from exclusive state to shared state on read miss. On read miss. Exclusive state to shared state on read miss. We are writing back data. So here we are writing back the data. This is what. Next, this is the bus action. Bus makes the process to write back the data on read miss here. Next, read B for P2. Previously, P2 has data A in its cache in shared state. Now P2 requests for B. So it was completely replaced, and read B miss was placed in bus, and P2 can get directly data from the memory and placed in cache B, and now it is in shared state. Now the cache is in shared state. Then, so as we are completely replacing the cache. Previously, the cache was with data A in shared state, and now it became data B with shared state. So we are moving from shared state to shared state on read miss, and we have seen the transition previously. Next, we have write of A. At P1 we have data A, but it is in shared state. In shared state we can perform only read operation. So it's a write miss again. So write miss was placed on bus, and no other process contains the same data, so there is no invalid signal. Then P1's cache moves from shared state to exclusive state, right? Next, here now we have operation read B. Already at P2's cache, data B is in shared state, so it's a hit. Shared state, and again we get a read on the same data, then we say it's a hit. Next, as B was in read state, shared state. So here we got an operation write B. So we place write B, as P1 doesn't contain data B, it's a miss. So write B miss is placed on bus, and there is a bus hit, as P2 also contains the data B in shared state. So we need bus sends invalid signal to P2. First bus sends invalid signal to P2. Before that, actually A was present in exclusive state. To perform operation on B, we need to replace the cache completely. So before performing that, we just write back data into the memory, as the latest copy of A is with P1. We write back in the data is written back into the memory, and the invalid signal is sent to P2 by bus. And now here the shared state was moved to invalid state, and then we can have B in exclusive state. Here we have B in exclusive state, right? Here it's B in invalid state. So here we are moving from exclusive state. Here A, the data A is present in exclusive state, and now the data B is present in exclusive state. So we are moving from exclusive to exclusive. Exclusive to exclusive on CPU write miss. If we observe here, it's a write miss. CPU write miss, write back data. We are performing write back here. Next, read of A for P2. As P2 cache is in invalid state, read A is miss, place it on bus, and we can directly read it from memory. P2 reads data from memory and places in cache. Now the cache state moved from invalid to shared. Next, P2 write of A. Here even it's a miss, as write of A, as P2 contains A but it is in shared state. So write miss has been placed on bus, and there is no bus hit as P1 doesn't contain A. So no invalid signal is generated, and P2 moves from shared state to exclusive state here. Next, shared state to exclusive state. As there are two ways of moving shared state to exclusive state. One is by generating invalid signal, and other is by not generating invalid signal. Previously we have seen by generating invalid signal, and now we are seeing by not generating invalid signal, and this is what that. Next operation is write B. As B was already in exclusive state, we are getting a write B operation, so it's a hit. Next, P2's cache contains data A in exclusive state, and now P2 gets operation write for B. So to perform that, write of B miss was placed on bus. As P1 also contains data B, there was an invalid signal. Bus generates invalid signal for P1, and then as B is in exclusive state, it's the latest copy, so it has to write back to the memory. So here write back operation is performed, then it made from shared state to invalid. Here we are making it's exclusive state. Exclusive state to invalid state by write miss. By write miss, we are making exclusive state to invalid state, and then now P2 reads B from the memory, and now it is in exclusive state. Previously P2 was in exclusive state, and now it's in exclusive state again. So this is what here we are moving from exclusive to invalid by read miss. So we are moving exclusive to invalid by, it's a write miss. We are moving exclusive to invalid on write miss, and we write back. Even we are performing write back operation here. So that's what. So this is what uh, write invalidate protocol. Thanks for listening. Thank you for sparing time. Thank you.